Good morning, mathematicians. Time for some algebraic topology, I guess. Time to keep going. Allegedly, there's a stream upcoming. I don't know if you guys knew that. Oh, and it started. Wow.
Mathematician.
Go figure.
Time for some algebraic topology, I guess.
What else is there to say right now while I set up chat? You know, I'm sure there's also a way to get all of this set up before the stream. But am I going to bother with that? No, probably not. Probably not. Okay. Homotopy extension property, right. So a rod. The following statements are equivalent. Aha, I see. Okay, so this is the kind of theorem I think I was looking for yesterday in order to help us. So to say that I is a cofibration is to say that I has the hep for the mapping cylinder. Today you learned K-theory is represented by a moduli space of n equals 1 supersymmetric quantum systems. Man, I have no idea what you're talking about, but good morning. K-theory is represented by a moduli space? Wait, are you telling me that the K functor is a representable functor? By homming into a moduli space of that? That's some crazy shit. That's some crazy shit. Disturbing, even some may say. Oh, you have no idea. Okay, good. Well, that makes two of us. That makes two of us. Right, okay. But yeah, so cofibration means you have hep for all spaces. Do I play video games? Not really. Not really. I used to a long time ago, but I don't know, it kind of feels like a waste of time. Which is a weird thing to say because the last 3 days I've basically done no work. I've literally sat around. I shouldn't say no work, I've done some work, but, and I taught. I'm teaching again today, but I don't know, I was just paralyzed for some reason. I was just sitting around doing nothing, watching slop on the internet. It's very weird, very frustrating, especially since it's like deadline for the thesis. But anyways, yeah. So even though, nonetheless, I find other ways to waste time. I've been playing a little more chess lately, and my rating's gone up, and piano and stuff. But I don't know. Video games just feel like a big waste of time to me, with the exception that last year, I still have my old PS3 tucked away in a closet, and I busted it out to play through The Last of Us with a friend who had never played it before. And then we also got partway through part 2 because his cousin had a PS5, but then his cousin moved. Oh, I didn't even know that, Arad. Is that like a basic, like what's the name of that result? Every cohomology theory is representable by a spectrum or infinite loop space? I didn't know that. Does that have a name? Do I follow chess as a sport? I used to. Again, not lately. I just feel like, again, I don't know. it's a fun hobby. Once in a while, I used to watch Gotham chess daily, and I would watch the World Finals and whatnot. But yeah, it's just like chess just feels to me. I love it, and I mean, for example, Brown's theorem. Okay, thanks. For example, um, what was I gonna say? Uh, yeah, I recorded myself playing a bunch of chess games for some of my recent interviews to have on in the background. Um, so I definitely still play actively, but it feels very self-indulgent isn't quite the right word, but like if I compare this to like the hobby of playing piano, it's like I don't know. I don't know. I was gonna say somehow like piano feels like something you can share, but you can also share in the joy of chess with other people. But there's still something about it that um, improving piano feels somehow more practical. I guess in a sense, it's not, but I guess this is just my own mind, my own psychology. Somehow, some part of it feels more practical, and chess feels more useless to spend that much time on. Uh, so yeah, yeah. And video games, I feel like even sometimes feel more useless. Sometimes I even feel this way about movies and TV shows. I'm like, is it just a waste of time to consume media like this? But I still do. Um, yeah, I don't know. But what isn't a waste of time? Why did I shave the beard? Because it'll be back in 2 days. Oh, it's the motivation for defining spectra in the first place. Um, oh, that's cool. And it partly motivates the construction of motivic spectra, so that algebraic K theory becomes representable. Okay. Depends on if you value joy. You wouldn't? Yeah. Yeah, sounds like a mistake. Okay, mapping cylinder is the push out of this. Yeah, so really that is I think we wrote it down the other day. It's just the disjoint union of these two things identified, right? Where um oh no, here, office hours. Delete untitled. Right, it's just uh so ZI, this should be AI union this, union 0, where we identify A0 in here and A0 here, or whatever, right? That's what it amounts to. Um, yeah, we just glue X. Yeah, yeah, that right. Applications of differential geometry outside physics. Um, I mean, what was... I was having a conversation with an applied person once. They were telling me something about some applied differential geometry. I don't really remember what it was now. I mean, it depends on what you call physics, right? I feel like by definition, a lot of applied stuff is, you could track it back to physics. I mean, uh, yeah, PDEs, yeah, PDEs, but yeah, I don't know. I guess it also depends what you mean by application. Yeah, if you're happy to take a field of math as an application, as am I. Okay, no one's corrected me on the mapping cylinder, so maybe I'm not wrong. My answer to everything is depends on what you call, yeah. That's true. I don't have answers for anything. Yeah. The truth finally comes out nearly close to a year into live streaming. I really have no answers. Um, yeah. Hello, Connor. Okay, so wait a second. Right, so if we can just show that I has the HEP for the mapping cylinder, then we're good. So does that actually make our disk example easier? What do I want to show then? Because the mapping cylinder... The mapping cylinder of this thing... Right, that's exactly the picture that Arad told me to draw the other day. Right, that's exactly that. Right. Right. And so we just take our inclusion here. No, wait. We have our inclusion here, and we have what, two... Oh, I see. This does make it... hello, Luna. I remembered correctly. I'm good. How are you? You've been anxiously awaiting the city tutoring rebuttal. Is it actually going to happen? Yeah, I don't think it's actually going to happen. Was there even really a rebuttal? Because he said he made a post. So maybe the post was rebuttal. It was just someone in chat here said, oh, he's going to make a video. You better watch out. But no videos arrived. There's another video by Wildburger where he says wrong things, and I thought about reacting to it. Yeah, I don't know. I might put out a video today for my discrete math students. You're good. You had your first paper come up on archive. Nice. Congratulations. Set theory, right? Should we go find it? Should we go find it on stream? Do you want to let us know? City tutoring outsourced it to you, and you have fire arguments. That will turn me into a little baby squirrel. Okay. What's the lifespan of a squirrel, by the way? Okay. Ah, I see. Well, if you'd rather not share it, then that's fine. Can you not Is it not possible for you to change it, or is it like for certain academic reasons, it's better for you to use your dead name? Or um, you just finished one of the longer lean games, like I suggested. Oh, which one? Which was the longer one? Analysis one's pretty long. But you feel like they only taught you how to write proofs using predefined objects like tactics. Zero info about doing custom stuff. Yes, unfortunately. Oh, it blocked? I mean, if you just tell us the title of the paper, we can go find it. If you just tell us the title of the paper. I mean, if I look at if I just pull up set theory here too, I mean, I see. Yeah, that makes sense. No, yeah, that makes sense. A formula for any real number. The real deal. Yes, you're here. Okay. But yeah, sorry about Jacobs. Uh, the maybe is actually part of the title. Nice. Okay. Okay. Um, but yeah, I did find, in previous attempts to learn lean, I did find, I played through the natural number game and I said, okay, time for me to write my own lean projects. And I did find there was a bit of a gap. It was a bit of a struggle to go from there to the next step. However, nowadays there are more tutorials on lean than previously. And what else was I gonna say? Yeah, there's more lean tutorials, and there's also the Zulip chat, which I don't know. To be honest, I don't like using Zulip. There's just something about the layout that's weirder to me, but okay. There's plenty of helpful people in the lean community that you can go talk to about getting started with actual projects. Yeah. Rod's already seen this paper. Nice. Ain't Zulip like math slack? Yeah, basically. I don't know. I just don't. There's just. I don't know. There's just something about the structure of how things are laid out in Zulip. It just rubs me the wrong way. I can't explain it. I can't explain it. Oh, it made the rounds of math sort of. Wow. Pretty famous stuff. Will people start using proof assistance if the UI has a cool rotating surface on the side? I mean, count me in. We discussed how to write three specific natural numbers, A, B, C, such that for any real number you've probably ever thought of, it is consistent with ZFC set theory that... What? Huh. Oh, okay. Weird. We also discussed why it's possible, assuming the existence of certain large cardinals. What the hell? For there to be a real number s, which cannot be the value of this formula for a particular. Okay, that is crazy. uh, Familiar mathematical constants are often defined or computed in terms of some infinitary process. Applied to only rational numbers. Yeah. Or I haven't seen this expression for gamma. Oh, I guess you're basically just taking the series expansion for log, or no, something else is going on here. But okay. Formulas such as these are so banal in the context of mathematics, it's easy to think they represent absolutely specific quantities. It'd be absurd to say that something like this is unresolvable by ordinary methods. Results. It's possible to show that there are natural numbers, D, E, F, such that the value of this is independent. What? That's fucking crazy. Really? It seems so simple. Wait, what are the ends? What are the ends here? Oh, it's... Oh, I see. It's overall. Uh-huh. Wait, I'm a little confused. Two I, were it just enumerating D? I'm confused about the indexing here. And N and E. Okay, so D is the largest of them, or I'm a little confused at the formula. Okay, anyway. D is the largest. Okay, and it's going to be the case that 2E3E is less than D? That's what was throwing me off there. Not your D. Paper discusses similar formula. Can consistently be any reasonably simple non-negative real number. Although, as we'll see, the relevant notion of reasonable simplicity is actually extremely broad, encompassing, for instance, every real number described by some entry on OEIS. What do you mean by how do you know? Are you just saying computable real numbers, or and all but 2 or 3 real numbers with their Wikipedia article? Okay. Wait, really? Did you check them all? Maybe there's not that many of them. Okay, yeah, I see. It includes all computable real numbers and many non-computable real numbers. Jesus. But what do we mean when we say that this is more independent? I assume just that there's a broader range of values you can actually get. There are 2 senses, which is true. The easier sense is just the set is larger. Okay. May only consistently take small, possibly only 2. The other sense is independent results. Fairly robust way. Group axioms. Different models of C can be thought as different universes. To see different values of the formula, one must go to different universes. By contrast, can change merely to passing the universe with a different set of real numbers. It's important for formalizing the central claim. Yeah. Set theory tends to focus on well-founded models. One thing I would like to learn more about is non-well-founded set theory. It seems more fun. Well-founded models are somewhat analogous to Noetherian rings. Right. Okay, that makes sense. Both play their role in their respective fields, but also on a technical level, they're defined by a finiteness condition. A model of ZFC is well-founded if it does not have an external infinite descending sequence? Huh? Wait, what? Hang on. A model of ZFC is well-founded if it does not have an external infinite descending sequence. Huh? Is this definition of a well-founded model one which does not include a model with an infinite sequence like that, even if xi is not a set in the model? But not see that it does? As in you can't prove it? Yeah, I don't understand what this means. So my naive understanding was that foundation just says you don't have a set that's contained in itself. It just said that you don't have this. But I guess maybe there's more refined versions. Can you not build a... No, I guess you can't. I guess you can't from the axioms. So I guess this thing about sequences is equivalent, right? I'm still not sure what it means by external. So that means that it could have one no, I'm not sure. Because ZFC plus existence of such a chain is consistent would imply can have such a chain with well-founded axiom? Huh? I do need your model theory video, which isn't out yet. There can exist a model of ZFC and a sequence and a sequence M that satisfies this for each I, but the full sequence is not in M? So the set containing each individual term in the sequence can be an M, but the sequence can't be. How is that possible? Because, right, I mean, if this set existed, then couldn't you form the function to the set that sends I to xi? And then, I mean, then you've constructed the sequence, right? So wouldn't this follow from the existence of A? M doesn't actually satisfy that there's an infinite descending sequence. Yeah, I'm very confused by this. You can't simply you can, Christian, you can nest the empty set n times, but you can't do it infinitely many times, not with the axioms of ZFC. If you think you can, Try to do it. Try to do it from definitions. It's not definable? What does that mean? How is this not definable? I don't understand. What does definable mean here? All our models will be well-founded, so you can move past it and think about it later. I guess. But I want to understand this point. What does it mean to... You can kind of do it to infinitely many times. This is an example of that? Wait, what? You can kind of do it infinitely many times? But how is that possible? No, you can't, because well-foundedness is independent of the usual axioms, right? I mean, I do want to understand this point. Okay, I'm going to read the rest of the introduction and then I'm going to go. Well-founded models agree about what the natural numbers are, but many have different sets of real numbers. Interesting. Really? Really? What does that mean? How is that? Really? How do you... How would that affect the real numbers? Thinking of axioms a naught in a1 in a2, and add axiom a naught equals empty? What? Now I'm very confused. The second statement is more independent, varies, and so it does. Models can have different sets of reals. I agree with that. I mean, that I'm aware of. Right, a countable model of ZFC can only have countably many reals. That I'm aware of, but what is surprising to me is that well-foundedness changes your set of reals. Like, hello, Adib. Like, it's very, like, because I'm just thinking, like, of course, if you can only have countable sets, like, of course it's going to change, or, like, if a countable model of ZFC, like, of course it's going to change your real numbers. But if you have, like, if I'm thinking about the construction, like Cauchy sequences or Dedekind cuts, like, there's no part of that seems to have any, like, no part of that in my mind has anything to do with foundation, right? I'm just like, oh yeah, I can form the set of, like, Cauchy sequences. So it's surprising to me that foundation would jump in. You're just claiming that well-foundedness fixes the naturals, but pointing out that it doesn't fix the reals. Yeah, I'm still not understanding that statement. I guess that you can't see in the external infinite descending sequence like this? Anywho. Actually, how much longer is this introduction? I gotta go soon. Okay, I guess the actual argument starts here. So let's see. Proof of main theorem, very similar to previous work. Yields a function whose Lebesgue measurability is independent of ZSC, intended to be vaguely self-contained. Not to highlight the relationship. Yeah. Some computably definable subset of Cantor space. Standard argument using effective descript theory. And a lightly number theoretic argument that this definition can be implemented by some relatively simple mathematical expression using ideas similar to those in the negative resolution of Hilbert's 10th problem. Yeah. Well, anyways, this seems cool. This seems cool, but I should probably get going with my day. Maybe I should film a video for my discrete math students and put it online. Some extra math. But I maybe we'll even come back to this tomorrow because I do want to return to these questions of like well-definedness, well-foundedness, well-definedness, and what it means, like why you say I can't define this function. I'm really curious about all of that because I feel like for me that's kind of a barrier to actually understanding anything in here. Oh, I see. Nice. Yeah. What are my thoughts on LLMs being used in research? Yeah, well, you'll have to ask me tomorrow because I'm taking off now. Yeah. Thank God for not sending you problems independent of ZFC. Well, so far, but you never know. Okay. QED.